problem is a little bit tricky, but it's not the worst problem we're going to do. But make sure you kind of understand how I do this. A mixture of SO2 and O2 are allowed to react to form SO3. So first off, I wrote out and balanced this equation. We'll use this, 298 Kelvin. It wants to solve for pressure, so pressure equals nRT over V. And here we go. So we have to find the number of moles, and the volume is given to me, so it's just finding N. Alright, so what I did here is I wrote that we had 0.2 of both of these to start. This question is actually a limiting reactant problem, and then a Pivnert problem second. So if you look, this one's not that bad because it's just a 2-to-1 ratio and these are the same value. This number must be 2 times bigger than that number. I had to pause for a minute there. So since this is not 2 times bigger than this one, this is my limiting reactant. Alright, so in the end, I'll have 0 of this left. Alright? Now, all of it gets used up. Now please look. That means that 1/2 of the oxygen value is used. So half of that is 0.1. I subtract, and that means I have 0.1 mole of O2 left in the flask. And then, this is nice, since this is a 2 and this is a 2, every amount of this that I use is equal to the amount of this that I create. So we now, at the end, are going to have 0.1 mole of O2 and 0.2 moles of SO3 and 0 moles SO2. If I add all of these, I now have 0.3 moles, and that's what I want because I can plug that into Pivnert. So P equals 0.3, R is 0.0821, T is that 298 Kelvin, and then the V was 4. I'll plug that in. That in, I ended up with 1.83 ATM is your pressure in the container. So hopefully that wasn't too bad. This is a problem directly off of an AP test back in the day. It's a good question to test limiting reactants without having to use a ton of technical math here, and then applying it to Pivnert.